Hello everyone. Today we will look at chapter Force and Motion. And the subtopic we will cover today is about impulse and impulsive force. For SPM Physics, this subtopic highlights two learning outcomes. So, at the end of this video, you will be able communicate to explain impulse and impulsive force. Also, you will be able to solve problems involving impulse and impulsive force. What is impulse? Okay, impulse known as the product of force and time of impact means impulse is equivalent to F times t. In another word, impulse also defined as the change of momentum. Wait, did you still remember what the momentum is? Don't worry, let's recap. According to the previous subtopic, momentum is known as P. It is defined as the product of mass and velocity. The formula of momentum is P equal to m times v, where m is mass and v is velocity. Now, let's get back here. When we talk about the change of momentum, the symbol is delta P. And for a constant mass, delta P is equal to m times delta V. Delta V can be written as V minus U, where V is final velocity and U is initial velocity. When we simplify, it equivalent to mv minus mu. Therefore, impulse is Ft equal to mv minus mu. And the unit of impulse is Newton second or kilogram meter per second. Look at the example of impulse. A tennis ball hitting the concrete wall and bounce back. From the information given, we know that mass m is 0.05 kilogram. The initial velocity u is 50 meter per second and final velocity is v negative 45 meter per second. Negative sign here is because the ball bounced with opposite direction. So, to calculate the impulse of the tennis ball is using the formula of mv minus mu. When we put in the value into the formula, so we will get the impulse of the tennis ball is negative 4.75 kilogram meter per second. Impulse is a vector quantity, so the negative sign here means the impulse was in the left direction. But what about impulsive force? Impulsive force defined as the rate change of momentum. Rate means it must be divided by time. So the formula is F equal to mv minus mu divided by t, where t is time of impact. Impulsive force also can be written as F equal to impulse divided by t. Since it is the type of force, so the unit is Newton, or we also can use the unit of kilogram meter per second squared. Look at the example of impulsive force. Same situation as just now. Impulse that has been calculated is negative 4.75 Newton second. If the tennis ball takes 10 seconds to bounce, so the impulsive force is, using the formula impulse divided by t. When we put the value into the formula, so impulsive force is equal to negative 0.475 Newton. Impulsive force is a vector quantity, so the negative sign here means the force was in the left direction. Impulsive force actually obeys Newton's third law. The law states that for every action there is an equal but opposite reaction, meaning that the magnetic force from tennis ball act to the concrete wall is equal to the magnitude of force received by the tennis ball. Now, let's moving to the effect of increasing or decreasing time of impact on magnitude of impulsive force. First, what will happen when we increasing time of impact? This is the situation. A girl is jumped on thick mattress of gymnasium. During landing, the time taken is longer. Thus, the magnitude of impulsive force will reduce. Look at the formula of impulsive force. When time taken is longer, so impulsive force is reduced. Second, what will happen when we decreasing time of impact? This is the situation. The pestle and mortar are made of hard materials. During pounding, pestle moves very fast, while mortar stops the motion of pestle in a short time. Thus, a strong impulsive force is produced, and chili can be broken into pieces easily. Look at the formula of impulsive force. When the time is short, so the impulsive force is strong. Now, let's moving to the situation involving impulsive force in the safety features in vehicles. Look at this vehicle. There are 5 safety features was designed. First, headrest was designed to prevent injury of head, which move back when car suddenly accelerates forward. Second, windscreen was designed to protect the driver from wind and temperature extreme. Third, crumple zone was designed to compress during accident. It will lengthen the time of impact and reduce impulsive force. Fourth, airbag was designed to prevent driver from hitting the steering wheel, dashboard, or windscreen. Last but not least, seatbelt was designed to prevent driver from being thrown forward. Now, let's try some questions. This is the situation. A nail of 0.02 kg mass is driven into a wooden block. Its initial speed is 30 meters per second and is brought to rest in 5 seconds. If I say that is brought to rest, means here the final velocity v is equal to 0 meter per second. To find the impulse, we are using the formula of change in momentum. Change in momentum is equal to mv minus mu. When we put in the value into the formula, we will get the impulse is equal to negative 0.6 kilogram meter per second. Next, let's find the impulsive force. We are using the formula of impulse divided by t. We are using the impulse that we calculate just now in A. So when we divide by 5 seconds, we will get that the impulsive force is equal to negative 0.12 Newton. Next, the crumple zone in front of the car is important for safety because it could reduce A. the time of impact, B. the impulsive force, C. the damage of the engine, D. the kinetic energy of the car. What did you think the answer is? As I mentioned before in 5 features safety for vehicle, the crumple zone was designed to lengthen the time of impact. So the answer is B, because it could reduce the impulsive force when we lengthen the time of impact. Okay everyone, that's all for today. I am Shuhada, and I would like to say thanks for watching this video. Have a nice day ahead.